Hi, everybody. So I am Matt Topol. I'm going to give a talk on ODBC takes an arrow to the knee. ADBC. See, I like puns and having fun. So before I get started, just to so you guys just quick introduce myself. Quick introduce myself so that you understand. You actually have a reason to listen to anything I'm going to say. Um, I'm Matt Topol. I'm part of the Apache Arrow PMC. I currently work at Voltron Data, but in general, my day job, I just work on Apache Arrow, ADBC, associated open source projects with contributing to others. And I also wrote the book on Apache Arrow, in-memory analytics with Apache Arrow. Got it right here. I'll have one copy with me in my backpack to give out every day. So if you're interested, just find me and maybe I'll still have it and I'll give you a copy signed by me. Yay. Um, and I'm easy to find on LinkedIn or Twitter. I refuse to call it anything else, but I'm easy to find. So, quick primer on what Apache Arrow actually is, because not everybody knows or understands it. Apache Arrow is a in-memory column-oriented data format. There are implementations for it in a truly absurd number of languages. Because it's a format, it's a spec, so it's very good for interoperability. And the more languages that have a library implemented that works with Arrow, the better, easier it is to interoperate amongst a lot of languages. Now, the point there is that Arrow is the same in-memory bytes as it is on the wire, which means that when you're passing Arrow data between systems, between nodes, you don't have to pay the usual serialized and deserialized cost as you're passing it around the system, which when you're talking about large distributed systems, that ends up being an enormous part of your CPU cost, is that serialize and deserialize every time data goes in and out. And so Arrow lets you get rid of that cost and also reduce copies elsewhere between runtimes. Now, if you're not familiar with the term columnar, column-oriented, just a quick little point showing off what it is. The idea being, the actual way that you lay the memory out to represent your table. A struct of arrays versus an array of structs type thing. By putting the data for each column in order in memory in that way, it enables a significant performance benefits in many use cases. When you're talking about, on disk I/O, you have formats like Parquet, which are column oriented, and you get reduced I/O because if you only need a subset of the columns, which is the most common scenario for any kind of analytics, you're not reading all the columns, you're reading a subset of columns. You only have to pay the I/O to read that subset of columns, and now you only have to. And then when you're performing any kind of vectorization, SIMD, and gaining performance from that, it requires the data to be contiguous in memory to use vectorization and SIMD techniques. By having the data already be in a columnar format in memory, the data is already contiguous and therefore makes it very easy to adapt to utilize vectorized and SIMD algorithms and get performance gains that come from that. So the point here is that you get reduced memory usage, reduced I/O cost, and much more friendly to vectorization, which is the point of using a column-oriented memory format in the first place. So now that we've established what Arrow is, so we're all on the same page, talking about things, let's talk about databases and operations. Now, the most common way that systems and applications interact with databases is going to be ODBC and JDBC. And I'm sure everyone, or most people at least, can find the humor in my little sheep there, who is claiming to be a JDBC driver, because anyone who's interacted with either ODBC or JDBC generally never has anything nice to say about it. But it serves a purpose. So when you're doing your application, you have the general workflow that you're dealing with. when you're dealing with JDBC and ODBC is like this. You're going to submit the query from the application using that API. The driver is then going to translate that to something database-specific protocol to send the query over. Database will execute and return their data in some database-specific format. The driver is going to then translate that result set from the database-specific format into something that fits the ODBC or JDBC API, which is row-oriented. And then the application can finally iterate the results coming out of that API. And that's kind of your standard workflow when you're dealing with ODBC and JDBC, as it has been for the past 20 some odd years or more, 30 something years. And there's pros and cons to it. JDBC and ODBC aren't going anywhere. They've been around, decades. They are still the most common way of interacting with systems and databases, and they have a wide support and entire industries built around developing drivers for systems to use them. So they handle nearly every case, and they're very versatile because of that. However, most analytics databases nowadays, most analytical systems nowadays, are column-oriented for all the reasons I said earlier. To benefit from improved memory usage, vectorization, reduced I/O, and so on. Which means that for your standard analytics database systems now are all a column-oriented data system that then transposes all of those data, all of those columns into rows for ODBC and JDBC. And then most applications are going to transpose it back into columns anyways to do visualizations, data frames, exploration, and so on. And those conversions, those transpositions, have a cost, a significant cost. And if you want to avoid that conversion cost, you have these integration costs, where now you can, if you don't want to use the ODBC and JDBC because they're slow, you have to use database-specific SDKs to get the column-oriented data out without the transposition cost. And then you have the case where you have to make new handlers and new connectors for all these different places. And then you end up with things like, if you look at the current scale of connectors for, say, Trino or Presto, and how many different connectors they all have. The amount of connectors you have to build if you want to avoid that conversion cost is enormous. And that brings us to what the actual talk is about: Arrow database connectivity being a better way to do things. So Arrow database connectivity is a similar concept to ODBC and JDBC. You have a single API that applications can code against. And then you have drivers that are swappable that implement that API that do the connectivity to the database system. The big difference is that ADBC is Arrow native. The data that comes through to the application and goes in is all using the Apache Arrow format, which means that's column-oriented the whole way through, which means that you get to avoid that conversion cost. Now, ultimately, it's an API with a bunch of drivers. And we have libraries and implementations in Go, Java, R, Python, Rust, and so on. And so it makes it very versatile and easy to use. And so let's look at that same diagram again. So that same workflow, but now we're going to use ADBC instead. Application submits a query via the API. Driver translates it to some database-specific protocol. Database executes it, returns it, ideally in Arrow data. If it returns it in the Arrow format, then the driver can just pass it on through. No conversion, no transposition, no serialization, deserialization, just straight pass through. If the database returns it in Arrow. If it doesn't return it in Arrow, then yes, you have a conversion cost, but you also end up with a really good argument to get that database to go, hey, why don't you support Arrow output? You'd get a performance benefit from doing that. Meanwhile, your application only has to deal with Arrow data the whole way. And then finally, you can iterate those roles. ADBC is a spec. It's an API. It's a header file. That's the entire thing. And then a bunch of libraries built around it. Because like ODBC and JDBC, it's an API that drivers implement. Applications build against the API, drivers implement the API. And we have various ways of enabling new drivers. We have some simple SDKs to help build new drivers for people who are building them. And we distribute packages for the drivers so that you can dynamically load them in the system as you go. Currently, we have Snowflake driver. There's an in progress BigQuery driver, Postgres, SQLite. DuckDB implements the driver, implements the interface, and so on. And of course, we semantically version it, so it's easy to keep track of and know when you need to update the protocol, when you need to update your driver, so on, to ensure that zero copy maneuverability. Because Arrow specifies a C interface to enable you to pass data across the C interface without copying it. You're passing pointers. And that's why we leverage that in the ADBC definitions so that you can eliminate those copies. So where does ADBC kind of fit when we're talking about general workflows? ADBC isn't going to or intending to replace ODBC and JDBC in general use. It's just not. We're not going to displace them. But whenever you're doing any kind of bulk data access for analytics or tables of data, bulk columnar data benefits, ADBC is going to be beneficial for you. It's going to be significantly more performant, and we'll get to that in a minute, show you how. But that's kind of where that fits. Okay? It's not going to, if you're doing transactional interactions, ODBC and JDBC are fine. You're not going to get much of a benefit using ADBC for a pure transactional row-by-row workflow. But if you're doing anything with bulk amounts of large data, ADBC is going to be beneficial. Now, if you've heard of Arrowflight SQL, the protocols, you might be wondering what the difference here. How, I already have Arrowflight or Flight SQL. Why do we need ADBC? It's a separate thing. It's an API versus the protocol. Arrowflight and Arrowflight SQL are protocols, whereas ADBC is a client-side API. And the end result here is that if you're building a data system, like a database or anything, if your server side implements Arrowflight SQL as your interaction on the server, you get all the client stuff for free, because then anyone can just use ADBC and the Flight SQL driver and interact with your system. But there's also Flight SQL drivers for ODBC and JDBC, because Flight SQL is a protocol. So if you build on the server side something with Flight SQL, you don't have to do any work to make clients exist, because they already exist, and it will just work. And that's kind of the difference here in the benefits of that API versus protocol discussion. I mentioned that DuckDB implements the ADBC interface. And so a while back, DuckDB, after they implemented the interface, did a quick benchmark test. And what makes it really, really useful about this benchmark is the fact that DuckDB is an embedded database, which means there's no network overhead protocol going on here, because it's all in process. This is literally the cost of inserting a whole bunch of rows and then doing a select star to get all those rows back, all in the same process which means that this is almost purely the cost of the transposition, that conversion from column to row in both directions. And you can see the dramatic difference in performance there, going from 28 seconds down to 0.7 seconds because there's no copying happening. The memory that DuckDB allocates to select the rows is passed right to the client via pointers, because DuckDB's internal memory format is almost indistinguishable from Arrow anyways, which means that they can have that zero copy interaction and just hand off the memory directly. And then the ADBC API takes that and just hands it off with the Arrow C interface, as opposed to ODBC and JDBC, which insert a whole mess of copies and conversions in there to do the proper maneuvering of the data across those APIs. And this kind of shows that power of taking a column-oriented data system and a column-oriented data format and keeping the data in that the columnar way end to end. So, how can you actually use it? Now we can actually let's look at some code, because I've told you all great things about it. How easy is it to use? Well, it's pretty simple. If you want to use it from Python, you can just import. You can just pip install ADBC driver Snowflake, ADBC driver SQLite, ADBC driver Postgres, so on, and we implement a high-level DB API interface. So you can just use the Python DB API interface stuff and utilize ADBC in that beneficial way. And then we extend the DB API slightly and add a fetch arrow table function so that you can just get arrow table, arrow data, a stream of arrow record batches if you want, straight from the Python API across the ADBC interface. Nice, simple, straightforward. Slide it right into your existing code, and it's just very useful. We also have a lower level API where you can import the driver manager directly. If you want to load, a custom driver or something that we don't already have a package in the ADBC repo about, you can just load any shared object that implements that C API. You can just load and use it and call it, interact with it using the ADBC API, the ADBC library in Python. This low-level driver manager exposing API is also so that you can easily leverage multiple drivers in the same process and swap between them, or have different connections in the same process, and so on. For example, DuckDB, if you pip install DuckDB, they actually export a Python wrapping the DuckDB, the ADBC driver manager, and so you can import ADBC driver DuckDB.db API if you have just installed DuckDB, and load DuckDB via ADBC. And your application interface using ADBC just stays the same, nothing changes. That driver manager is basically a shim. It implements the ADBC interface by delegating it to a dynamically loaded object, so that you can leverage and you can also decouple your system from the drivers. Because you could link against the driver directly if you want to, but that makes that connection very tight. Instead, you can decouple it by using the driver manager and then dynamically load drivers on the fly as you need them, as you want them, and use them. It also means that we don't need to have the drivers implemented in C and C++. The driver can be implemented in anything that can create a shared object that can create C functions. In fact, several of the drivers are written in Go purely because it makes it much easier to package them. Because Go easily and by default does a bunch of static compiling, and static linking. And so you have drivers written in Go, like the Snowflake drivers written in Go, because we have a single binary to distribute. That's it. It has a dependency on libc, and that's it. Makes it super easy to distribute as a driver to load by any application that wants to use it. And so if you're using ADBC from Go, you can use it with the default standard library SQL package if you want, or you can just use the ADBC interface directly and get Arrow data out straight through it. Conceptually, everything's kind of similar. Whether you're looking at, the breakdown is very similar. Whether you're looking at the connections, you're looking at, the queries, the query state, prepared statements, all those conceptual ideas are all the same. They all work the way you'd expect them with ADBC. We try to simplify things a little bit because if anyone's ever actually implemented an ODBC driver, you know how ridiculously hard it is to get the cross-section of everything you need to implement for it. So ADBC has a smaller cross-section of functions you have to implement, smaller interface, much easier to utilize. And then you get to benefit from all the performance and the column orientation of the memory and just Arrow in general. In addition to simple query, query, execute, return data, ADBC also implements a few other useful pieces in its API. You've got bulk ingestion. You can take a stream of Arrow data and ingest it right into a table if the driver implements that. And you can either create a new table or do an append or whatever. So not only are you going to have the benefits of Arrow and column-oriented data on select and output, you get that on the input too. Which then means, when you think about it, you can load a driver, an ADBC driver, connect it to DuckDB, load another one connected to, say, Postgres. You can do a query to select from DuckDB and do ADBC ingest and just stream the result into Postgres or vice versa. And so now you just significantly reduced your memory usage if you need to do that kind of cross-database, copy, because not only are you benefiting from the zero copy of Arrow, you're streaming it across, you don't have to get the whole memory, the whole result set in memory first before you pass it along. You can just connect ADBC drivers with each other for ingestion and query execution if you want to. Some execution systems, some compute systems also will partition your results on the back end to make it more easily to parallelize, refetch, and requery and request the data. And so ADBC supports that, especially useful for things like Flight SQL, which enable that as a protocol level. And then ADBC allows you to benefit from that at the API. And of course, with anything database-wise and SQL in general, the ADBC API does support transactions because, well, people would shoot us or won't use it if we don't. So that's pretty much everything there. If anyone wants, I also have code examples and other scenarios that I can show off and do examples for people. But in general, that's kind of the long and short of ADBC in general. I said in general way too many times there. But that's the long and short of it. If you want to learn more about Arrow in general, I keep saying that. Wow, stop. If you want to learn more about Arrow, you can go to the Arrow docs. The website is very helpful. We have a lot of documentation for most of the implementations. There's even Arrow cookbooks on learning how to utilize it in various ways. Then there's also the actual ADBC docs, which is the website on the slide, which has quick starts, mostly the pip install things you saw earlier in my previous slides. It has how to install it using C# or other languages, and so on. You can also get my book, fresh new with the second edition, with an entire chapter on ADBC. Shameless plug. So, But there's practical examples. The book covers C++, Python, and Go examples using Arrow, ADBC, Flight, and Flight SQL, and help you kind of get into the ecosystem in general. Help you get into the ecosystem. And so that's kind of a wrap there. And lost my question slide. Anyways, take questions then. Yeah. So Polars is entirely built on Arrow. Its entire internal memory format is Arrow. Well, you can you can use you can take the output from ADBC and just send it and wrap it to Polars as a data frame, and it will just work because it's Arrow. Polars has things for reading from Arrow streams, and you can also export to an Arrow stream from Polars. So because you can easily do that conversion to and from Arrow data with Polars in a zero copy way, you can use that to talk to ADBC from Polars. You just have to do the intermediate to Arrow call. Same thing for Pandas, has the same thing. You can do that intermediate to Arrow or to Pandas calls to do the switch between Arrow and Pandas, but it will in most cases be kind of zero copy. It's just the extra function call to do. Not currently, no. You'd have to talk to the Pandas project about that. You'd have to talk to the Pandas developers about that. Yeah, it'd be awesome. Oh, so like the primary contributors of the C# bindings for ADBC are a pair of Microsoft Power BI guys. Yeah, that's what I'm hoping for. And also back in March, when Microsoft made their public announcement about Fabric supporting Snowflake, if you look at that announcement, you look at the docs, there's little parentheses, powered by ADBC. They're using the Snowflake ADBC driver. So hopefully they'll dig more into it and you'll get more support for it soon, but nothing public. They haven't said anything public about it yet. Yeah, there is work happening for those, yeah. Especially with like Spark Connect already uses Arrow, and then there's also work happening to provide you a direct Spark driver with ADBC, which is really cool. Yep. Anyone else? Questions? Yes. Mm-hmm. Mm-hmm. What I would say is normally there really isn't like a rule of thumb I would go with. I know that depending on how expensive the actual database computational side is, then you might not get that much of a benefit with ADBC because of many of those systems, even their ODBC drivers, are already transporting the data in Arrow or other formats and then just doing conversion locally. It also depends on the number of columns you're talking about. So, I would say maybe if you're looking at data that might be on the order of, hundreds of megabytes, gigabytes of data in your response, you're definitely going to see a benefit from the Arrow from using ADBC there. At smaller data sets, you might not. It really depends on a lot of factors. But the other benefit there is the fact that it is a single API to code against, and the fact that you're getting Arrow data directly out of it, which makes it really, really efficient to feed right into polars or pandas or those. So even if you're not going to get necessarily a performance benefit from ADBC versus ODBC because you have a small data set, you're still going to get the benefit of that interoperability. No problem. Anyone else? Any questions? Well, if no one has any questions, I guess I finished a little bit early. Thank you.